So we continue to look at inverses of matrices, and we're going to look at the inverse of a 2 by 2 matrix. And so it turns out that a general 2 by 2 matrix, so it has maybe entries A, B, C, and D, let's say. There's a formula that allows us to find the inverse of a 2 by 2 immediately. Now this doesn't work for any other sizes, 3 by 3, 4 by 4, whatever. No, you have to do a bunch of work. But for just 2 by 2, this guy's going to be invertible if and only if. So that's my little double arrow here. So that's, maybe I'll write that. If and only if AD minus BC is equal to 0. And so this number here is called the determinant. And you don't need to know that for now. Probably you already know this. You've seen it in some calculus course or something like that. We'll talk at length about determinants in chapter 3, but for right now we don't actually need the term. But it turns out that a matrix is invertible. A matrix of any size is invertible if and only if the determinant is non-zero. So, non-zero. That's kind of a key point. And in this case, we can write that a formula for the inverse. A inverse is given by 1 over the determinant times, and then we make this matrix by swapping the two diagonal entries. So we put the D here and the A there. And then for the off-diagonal entries, they get a minus sign, minus B and minus C. Okay, so let's look at an example of this. So if I take A to be the matrix 3 minus 2, 1 minus 1, then A inverse is going to be, so let's see, so we do AD minus BC. So AD, that's going to be 3 times minus 1. And we're going to subtract BC, which is minus 2 times 1. And that's what we're going to have as our normalizing coefficient out front. And then we are going to have, let's see, so we swap the 3 with the minus 1, and we have minus 1, 3. And then we negate the minus 2 and the 1, and so we get a positive 2 and a minus 1. So we have this guy here. And then looking at that denominator out in front here, that's actually minus 1. So doing the scalar multiple, multiplying the matrix by minus 1, we get 1 minus 2, 1 minus 3. And so we can check that this is in fact the inverse by multiplying one side of the other. So if we do A times A inverse, this is going to be 3 minus 2, 1 minus 1 times 1 minus 2, 1 minus 3. And let's work out the matrix product. So we have 3 minus 2 times 1, 1. So it's going to be 3 minus 2, which is 1. And then we have 3 minus 2 and minus 2 minus 3. So those are going to be the same terms, like 6's, but with opposite signs. So that'll give me a 0. And then I have 1 minus 1, 1, 1. So that's going to be a positive 1 and a negative 1, also going to be a 0, sum to 0. And then I have 1 minus 1, minus 2, minus 3. And so that's a minus 2 plus 3, so that gives me a 1. And I have obtained the identity. And if I do it the other way around, A inverse A, then let's see, so I'm going to have this guy here, and this guy here. Then this is going to be, so I'll have again 1 minus 2, 3, 1, so that's 3 minus 2 is 1. And 1 minus 2 minus 1, that's going to cancel two 2's with opposite signs. Other diagonal is 2 3's with opposite signs. And then I've got minus 2 plus 3 is 1. And I get the identity again.